to solve another Leetcode problem. 2192. All ancestors of a node in a directed acyclic graph. So let's first understand what is an acyclic graph. So an acyclic graph just means there's no cycles in a graph. Yeah, so this means while we are using the DFS or BFS to traverse, normally we don't need the weighted set. Yeah, because it can never go back, because it is a directed graph and it is acyclic. Yeah. Now let's try to understand the problem. So for this problem, we are going to calculate the node, for example, at position 0, index 0. Yeah. So for 0, it didn't go through any node, so it will be empty. But so let's check the last one, node 7. So for node 7, so what is their parent? So their parent is like 2, 3, 0, and 1. So we're gonna put 0, 1, 2, 3 inside because the node will be sorted in increasing order. So this is just according to the question. As we know that if we're gonna traverse just from like node 0, 1, 2, or 3, 4, we will not get the right result. For example, if we're gonna traverse from 7, there's no node even from 7. So this means we're gonna reverse the edge. So if we reverse the edge, what's gonna happen? So just for the 7, for example, we're gonna reverse, 7 to 2 and 7 to 3. Yeah, we reverse the directions, and 3 to 0 and 3 to 1. Yeah. So what's gonna be the result? So the result for this node 7 is gonna be 0, 1, 2, and 3, because we can use the DFS directly to solve the problem, because we can directly using a DFS to search the result. So this is why we're gonna reverse the edges of the graph. After reversing, everything gonna become really easy. Yeah. So for example, if this is a 7, we're gonna put 0 like 3, 4, 0, 1, 3, and 2 inside a weighted set. And then we're gonna turn this weighted set into a list, and then we're gonna sort it. Yeah. Now let's just get started for the coding part. So I'm gonna prepare a adjacency list as default date list. Now I'm gonna prepare the graph. So for UV in edges. So currently I'm gonna turn the direction. Actually, turning the direction is just easy. So before we turn it, it should be gu.append. Yeah. Now it should be gv.append. Yeah. So this is just the reversing part. So this means for node 3, it's gonna be traversal. Its neighbor is gonna be 0 because we reversed the graph. Yeah. Now let me just prepare the DFS part. Yeah, I'm gonna give a pass. Now let's go to the main function. So I'm gonna check in all the result. So I'm gonna prepare a dictionary first. So it's gonna be the default dict, and inside it's gonna be a list. Yeah. Now I'm gonna check all the nodes because I'm gonna prepare the result. So for I in range n, I'm gonna prepare a weighted set. So weighted set, I'm gonna prepare it as an empty set. Yeah, I don't need to put any nodes inside because it is not necessary, because this graph is acyclic. It means it can never go back. So I will put nothing inside. And then I'm gonna execute the DFS for this I node. So after executing, I just need to put the result in my dictionary. So di should di should equal to sorted. I need to sort the weighted set. Yeah, it should be sorted list with the weighted set. Yeah, so everything inside will be sorted. After that, I'm gonna just return list d.values. Yeah. So this is gonna be the final result, but we need to write the DFS. Yeah. So for the DFS, so for y in di, y is the neighbor. Yeah. If y not in a weighted set, so weighted set should add y, and then we're gonna execute the DFS for this y. Yeah. So in this way, the DFS will find all the children of 7 because the graph has already been reversed. So we're gonna put 0 like 3, 2, 1 inside the weighted set, and then we're gonna put it inside the dictionary, and then we're gonna output the dictionary. Yeah, let me check if there is anything wrong with my code. As you can see, it works. Now let me submit it. As you can see, it works, and the time complexity is just the number of edges plus the number of vertices. So let's just check the number of edges. It is 1000, and the number of vertices it is 1000, and number of edges it is minimum 2000. So the time complexity would be n plus m. Thank you for watching. See you next time.